Welcome to today's Explainer. We're going to be exploring the incredible, totally invisible journey of a single memory. We're popping the hood on the human mind to see exactly how we take in the world around us, process it, and lock it away for later.
You know, we all complain about forgetting things, right? Misplacing our keys, forgetting a coworker's name. But have you ever stopped to ask yourself, what actually is memory? It's a seemingly simple question about how your own mind works, but the mechanics behind it? Absolutely fascinating. Okay, let's dive into this. Memory isn't just some static, dusty filing cabinet in the back of your brain where you just dump facts. Not at all. It's a highly active, dynamic mental process. It's an entire system designed to store what you've learned and, this is the crucial part, retrieve it so you can respond correctly when a situation actually demands it. To map out this mental machine, we'll be looking at four main areas today. First, basic memory processes. Second, the stages of information storage. Third, episodic and semantic memory. And finally, metacognition and learning strategies.
So let's kick things off with part one, basic memory processes, or what we can call the three-step assembly line.
I really want you to picture your mind as a highly active assembly line, rather than just a passive box. Every single piece of information you learn literally has to survive these three fundamental steps. First up is encoding. This is the initial stage where your brain takes in raw sensory info, stuff you see or hear, and translates it into a format it can actually process. Next is storage, which is just how that information is kept safe after it's processed. And lastly, retrieval. That's the act of pulling the information back out when you need it. If this assembly line breaks down at any of these steps, well, the memory is lost.
Moving right along to part two, stages of information storage. Let's look inside the vaults.
So if that's the process, where does the actual storage happen? Well, the whole flow of data from the outside world into your brain is really quite something, and this brilliantly illustrates that journey. Input hits the sensory register, makes its way to short-term memory, and eventually, if it makes the cut, it gets locked safely away into long-term memory.
Let's zoom in on that very first stop on the journey, the sensory register. This is an incredibly quick holding area. When you see a sudden flash of light, smell fresh coffee, or hear a passing car, those sensory stimuli linger here for a mere 3 to 5 seconds. I mean, that is barely enough time for your brain to even interpret it and decide, hey, is this worth paying attention to?
Now, if your brain does decide that sensory input is important, it moves into short-term memory. The source material uses a really great metaphor for this, the blackboard of our mind. It's basically a temporary mental workspace. It reflects whatever we're actively thinking about at any given moment. But there's a catch. It has a super limited capacity, holding on to info for maybe 20 or 30 seconds before it's either wiped completely clean or passed on to deeper storage.
That brings us to part three, episodic and semantic memory. Time to enter the archives.
So what happens when we need to remember something forever? Welcome to long-term memory. Unlike that quick 30-second wipe of your mental blackboard, long-term memory has an unlimited capacity. It literally acts as a permanent record for absolutely everything you have ever learned and retained over your entire life. Now, what's really interesting about this permanent storage is how we categorize information into two distinct, fascinating divisions. You can think of your episodic memory as a sort of mental personal journal, while your semantic memory acts much more like your personal encyclopedia or dictionary.
Let's make that comparison totally concrete. Episodic memory is tied to specific times, places, and life events. Think of it like remembering, hey, I saw a lion at the zoo last year. It's all about your own personal history. Semantic memory, on the other hand, is purely factual. It's general worldly knowledge. It's knowing the core fact: lions are carnivores. You see the difference? You don't need to remember the exact Tuesday you learned that fact to know it's absolutely true.
And finally, part four, metacognition and learning strategies, hacking the system.
All right, now that we understand the basic machinery, from that quick 3-second sensory register all the way to our permanent mental encyclopedia, how do we actually use this to our advantage? Well, it all starts with one core concept, metacognition. Simply put, metacognition is the awareness of your own cognitive processes. Basically, it's thinking about your thinking. When you become aware of how your memory assembly line actually works, you can step in, take control of the process, and become a vastly better learner.
So the crucial point is how we actually apply this awareness to prevent ourselves from forgetting. The source material outlines 4 highly actionable strategies. First up is rehearsal, which is consciously repeating information over time to keep it active. Second is deep processing, creating really strong foundational connections. Third is elaboration, where you expand on the information to make it personally meaningful. And fourth is constructing images.
To perfectly demonstrate that last strategy, constructing images, the text provides this brilliant, slightly hilarious example to help remember a concept. The angry bird shouted at the white dog. Try picturing that. When you use your imagination to create a vivid, bizarre, or highly specific mental image like that, your brain links the information so much more securely than if you just sat there trying to rote memorize a plain old list of words.
We've covered the whole shebang. The 3-step assembly line of memory, the vaults where it's stored, the difference between your mental journal and your encyclopedia, and the strategies to hack your own recall. So, I'm going to leave you with this direct challenge. How will you change your study habits now that you actually understand your own cognitive processes? Next time you need to learn something, don't just blankly stare at a page. Use metacognition. Build an image, elaborate on the facts, and take total control of your memory.